Okay, it's enough. We're tired that the pi number gives more importance than other numbers. Today, we want to talk about one of the most important numbers of the mathematical world. Today, we're going to talk about the Euler's number, most known as the E number. That is most known as 2.718. And there you go. Okay, now, what's the difference between pi and the E? Now, pi have infinite decimals, but these decimals doesn't have a pattern, so that makes pi an unique number, so as E. Okay. Also, both of them are irrational numbers. Okay, and transcendental. So there is no such a big difference between these two numbers. The only thing that changed is the use of them. Okay. Now my co-workers are going to show you the history of the number E and how it works.
Now I'm going to talk about the history of the number E. The number E first comes into mathematics in 1618 when, in an appendix to John Napier's work, a table appeared giving the natural logarithm of various numbers. This table was written by William Euler. Then, in 1668, Nicolas Mercator published Logarithmotechnia, which contains the series of expansion of logarithm of 1 plus x. In this work, Mercator uses the term of natural logarithm for the first time for logarithms to base E. Later, in 1683, Jacob Bernoulli tried to find the limit of 1 plus 1 over n to the power of n as n tends to infinity. He used the binomial theorem to show that the limit had to lie between 2 and 3, so we could consider this to be the first approximation to found E. Finally, in 1748, Leonard Euler published Introduction in Analysis Infinitorium. He showed that E equals 1 plus 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial and so on. And he also proved that E is the limit of 1 plus 1 over n to the power of n as n tends to infinity. Euler approximated E to 18 decimals places. So E is 2.718.
Really nice things about this irrational number E, but what does it truly means? It is related to exponential growth as fast to compound interest. So the first definition of E is that it is the limit of 1 plus 1 over n to the power of n when n tends to infinity. What does it mean? Let's make an example. You tell the bank, okay, I'll invest $1, and the bank tells you, I'll give you 100% of interest in the dollar you get me annually. I know there's no bank that will give you this kind of interest, but let's suppose 1 plus 1, in a year you'll receive $2. But you're smarter than the bank, so you'll tell them, okay, let's reduce the interest to the half. You'll receive 50%. In 6 months, you'll have 1.5, and in the other 6 months, you'll receive the half of this plus what you had before. It means 2.25. Better, do you see? This means that as this number increases, the interest would increase too, but it will not increase to infinity. It will increase till it reaches the value of 2.71828 and so on. This is why this is related directly with compound interest, as its formula is that the future value equals the present value times 1 plus the annual rate of interest over the period to the power of the period. Another definition of E is that it is the sum of the infinitive series. means E equals beginning in 0 and tending to infinity of 1 over n factorial. This means 1 over 1 plus 1 over 1 plus 1 over 1 times 2 plus 1 over 1 times 2 times 3 plus 1 over 1 times 2 times 3 times 4 and so on. Another fact of E is that when we draw the exponential graph, we could notice that each point in this graph equals e to the power of x. Also, the area under the curve is equal to e to the power of x. So, when we are defining the natural logarithm of a positive number k, the definition of it is that is the area under the graph of the curve 1 over x, beginning on x equal to 1 and going to x equal to k.
Okay, fun fact. It can be represented as a continual fraction. Okay, it looks like this. So it looks like this. Fun fact.
A trick to memorize E is to just remember 2.7 and afterwards notice that 1828 will appear twice. And then you just have to put the most important angles and triangles as it will appear in this order. For example, 45.